All right, everybody say hi, Quiz Bowl. Hopefully you're doing good.
Hi.
Hi. All right, hi, Quiz Bowl. Okay, so 5, 6. What I told them just now, for you people who are watching this video, I'm only going to do section or numbers 1 through 4, and then maybe I'll add an example because there's one other example I kind of want to talk about. So we'll do like 5 examples, these first 5 examples, and then I have a worksheet that I'm going to give you per your request. We're not going to do the homework assignment on the board. We're going to do the worksheet, and I'll have you just do the front side of it, okay? The back side is all these story problems that we're going to do, and that's what your assignment will be tomorrow, okay? So a couple of you guys just asked, this thing here, we've done these formulas before for like radioactive decay and compounding interest and stuff, and we would have problems that say, how long does it take for this to become, $2,000 if it's $1,000 to start with, and you guys would take and plug in and try to get a number really close on your calculator. Tomorrow is when we're gonna learn how to do that without having to guess and plug in, okay? So that's what tomorrow is coming. For now, we're just gonna be dealing with these functions and solving them, okay? So these are gonna go kind of fast today. I'm going to have a cheat sheet up here at the top, and this is going to tell you what to do, okay? So exponential functions versus log functions, all right? There's a lot of exponential functions on here, and then I'm going to show you how to treat it if there's a log. So this is going to be the added examples that I'm going to do. They're going to be log functions, all right? So for exponential functions, you're going to do one of 2 things, okay? So 2 different things that you're going to do. If you're given an exponential function or an exponential equation like this first one does not have any logs in it, and there's an equal sign right here, right? What you're going to first try to do to solve for x is to change the base. Okay? So, look at example 1. This is a really good example for changing the base. Example 1 goes along with change the base. This is your first strategy for solving an exponential function. And we've already done ones like this. 8 and 2 are my 2 bases that I have right now. 8 and 2. And what I want to do is I want to make them exponential functions so that they are the same number. Okay? Like, this 2 can stay here, right? He's 2 to the x plus 1. We're just going to recopy him down. But can you write 8 in terms of the base 2?
Yeah.
8 is like 2 to the 2 to the third. So I'm going to make this 8 come down, and I'm going to make him 2 to the third power. But this x is still there. I have to bring that x down with him, right? Does that make sense? Yeah. 8 is changing to 2 to the third power. That x is staying, okay? And then these 2's, since they're both the same base, I have a 2 here and a 2 here, they cross off. So now I am just simply solving 3x equals x plus 1. Does that make sense? Those exponents are equal to each other. This 3 and this x combine, they're just being multiplied together. So 3x equals x plus 1, and then I just solve like normal, right? I'm going to subtract the x over. What's 3x minus x? 2x. I have algebra kids that say just 3, right? Because you're subtracting the x off. Whatever. Divide by 2. X is 1/2, and that's how you solve. Okay? Good? Yeah. That's how you do that guy. That's strategy number 1. You look at your 2 bases, 8 and 2, and say, can I make those the same number? Okay? Strategy number 2 is 5 and 2 are the 2 numbers that I'm looking at. Okay? So this one you treat a little bit different, and here's what you do. 5 and 2, I first try strategy number 1. I try to get those to be the same number. But can I write 5 as like 2 to the third power or 2 to the second power? Can I write 5 as 2 to any nice looking power? No, you cannot. So what you have to do is strategy number 2, which is ln to both sides. Okay, this is like example number 2 goes along with this one. Number 2, you take ln of both sides. Okay, ln is natural log, right? Natural log. All right, ln is natural log. So I'm going to go down here, 5x equals 2. And what I'm going to do is I'm going to slap a natural log on the front of it. So I'm going to take ln of 5 to the x power equals ln of 2. So I'm like trapping those 2 equations that were equal to each other, and I'm putting them inside of ln's. And as long as I do that to both sides, it stays equal to each other, right? It's legal, right? Okay, now, there's one really nice fancy thing that happens with logs and exponents with this x that's up there. What can we do with that thing?
Put it to the front.
Move it to the front, right? I can put that x in the front. So this really says x times ln of 5 equals ln of 2, right? There's kind of an imaginary times in between there. And if I'm wanting to solve for x, how can I get rid of the ln 5? Just divide ln 5 to the other side, right? Okay, he's gone here. Divide by ln 5. So x is equal to, what's ln? Now, we're just going to type it into our calculator. We're just going to type in ln of 2 divided by ln of 5. Okay, now, if you do this like in one line and don't do something over something, make sure that when it opens parentheses, you close the parentheses after the 2. Okay, so make sure you do that. So what is it? What?
0.43.
0.43? Yeah? Is what x is?
Yeah.
0.43. Yeah?
Yeah.
Makes sense? There's that. Okay, now, I usually use ln to put in front of both sides, but technically, if you're one of the people that likes to use log instead, you could technically put log base 10 in front of both sides. It does not matter which one you use, right? So I could have done the x in front, and I could have done x equals log 2 divided by log 5, because it will give me the same answer. So if you want to use the ln button, put ln in front of both sides. If you want to use the log button instead, put a log in front of both sides. You'll get the same answer, right? So I'm going to go back up to the top here, and I'm going to say ln to both sides or log to both sides. It doesn't matter which one you use, okay? They both will do the same thing as long as you simplify him correctly, okay? So exponential functions, that's how you're going to treat him, okay? Good? Okay, they have 2 more examples for exponential functions, and here's this, example 3. They have this guy right here, which is the same as example 2, but just a little bit uglier, okay? So here we go. This guy, 2 and 3 are my bases. So strategy number 1, I try to get those the same number. Can you write 2 and 3 as the same number? Like 3 can be written as 2 to some power. That doesn't work, right? So we do number 2, we're going to ln, or you can do log, doesn't matter. I'm going to ln. I like to use ln.
Can we skip a step and write the exponent?
You sure can, whatever you want to do. So when you take this guy down in front, make sure that if he's a big long exponent, you put parentheses around him. So he looks like this, ln2 equals this guy, 1 minus x goes in the front, and ln3. Okay, now this is a little bit uglier, but it's not too bad. What I do in this case is, rather than dividing the ln over to start with, which you're more than welcome to do, you can do that, I switch these both to decimals. So what is ln2 in your calculator? Give me that decimal.
0.693.
0.693, okay, and what's ln3?
1.09.
1.09? Yeah. Give me one more decimal. 1.09. 8, okay.
0.099.
0.99 is rounded?
Yeah.
Okay,
Yeah.
0.99. Okay, now, this guy says 4x minus 1 times 0.693, yeah? And you distribute that through, right? Like you back distribute it, right? Okay, so we're going to multiply him through, and we're going to do the same thing for the 1. 1.09. We're going to back distribute him through.
0.693.
0.693 times 4, what's that become?
2.772.
2.772x minus, and 1 times that is just 0.693. Are we following so far? We're doing a good, okay? Okay, this one, 1.099 times 1 is just 1.099. And then minus that times x is 1.099x. We're just back distributing that as well. Okay, 4 pieces up here. We've got 1, 2, 3, 4. These guys have the x's, so we want to get them together.
Mm-hmm.
Which one do you want to move?
Add the far
Yeah,
right one
I
over.
like getting that to be a positive. So this is just like normal algebra, except they're really ugly numbers, right? Okay, so he's gone now.
And add the 0.6.
And then you want to do that at the same time? Can we do that at the same time? Plus
Yeah.
0.693 plus 0.693. Okay, so he's gone from over here. So on the left side, I don't know, like
3.871. Yep.
3.871. X equals, and then if you add the 1 to the 0.693, whatever, 1.792. Now what? Divide by 3.879, or 71. And x is something, like 0.5 something, maybe.
0.463.
0.463. Yeah, there you go. Okay, so a little bit uglier, but still using strategy number 2, right? Sure. Still using strategy number 2. Okay, good?
Yeah. I could have been way worse.
Wasn't too bad.
Okay, I'm going to change this fourth example. I'm going to get rid of the minus e to the negative x. Let's do that real quick. So just e to the x equals 4. Let's just treat it like that. Okay, this is still an exponential function. What are the two bases that you're looking at? E and 4. Can you get those to be the same number? No. So strategy number 2 it is, right? We do ln to both sides. Now this is why I like to use ln instead of log, right? Because ln and e, what happens to ln and e? Crosses out, so I just have x equals ln 4, and then you can solve that as a decimal, right? That makes sense?
Which is 1.386.
1.386. There you go. Okay? Blink and you miss it. I just didn't like that problem with the minus e to the negative x. Because it's super gross and I don't like it. So I'm not going to do it.
What is in front of?
You just did ln.
Oh, the
ln to
E.
both sides.
Oh, okay.
Yep.
Can you zoom up a little bit?
That?
Yeah.
Okay?
Did we put anything underneath the log?
No, not yet.
Okay.
We're going to. I'm going to add maybe like 2 more examples off to the side over here. Yeah. Okay, good? All right, I'm gonna add 2 more examples off to the side over here. So do example 5 and example 6. I'll make these short. Example 5 and example 6. What?
It's okay.
Well, yeah.
It's whatever.
Example 5, example 6, whatever you want to list them as. Okay. Do log. You guys already know how to do these. Log base 2 of x plus log base 2 of, let's make it interesting. Let's do 2 log base 2 of x plus log base 2 of 5 equals log base 2 of,
We had to do these on our assignment.
you put me on the spot now. I can't think. 125, sure. 125. Let's do it.
Yeah, I literally said that.
125. Okay. Now, this is strategy number 1 for a log. Can I write out the next example before we do this strategy? Or before we solve that one? Okay, strategy number 2. Let's say ln, we'll solve them here, but I'm going to compare the two. ln of, let's do 2 plus ln x equals 2. Let's do that. Equals 2. Okay? So, strategy number 1 versus strategy number 2. Here's your log stuff, right? Okay. Things that I notice about the first strategy. I have logs on both sides. Here's my equal sign. I have a log here and a log here. Now, before we do this, we have to put these 2 logs on the left side together. But the thing that I notice is that there is a log on both sides.
So logs can cancel out.
Yes. So, strategy number 1 for logs. If log equals log, you cancel the logs. Okay? If log equals logs, you cancel the logs.
Do they have to have the same base?
Yes. Yes. But I don't think they'll ever give you something that's not the same base. So, log equals log, you cancel the logs. But you can only cancel log on one side and log on the other side. So we have to somehow, some way combine these 2 together over here. Okay? So, now, before we do combine the 5 and the x, this 2 needs to go somewhere. So that's why I put that little element in there. That's x squared now, right? It's x squared, not 2x, okay? Now, plus, we're going to put those together. Plus means multiply. So what are we multiplying? X squared and 5. So that becomes 5x squared. Yeah? Equals log base 2 of 125. You see that?
Why didn't we cross anything out?
What do you mean? Because we have to combine the logs before we can cross out the logs. There, you can only cross out one with one, right? So now this log is going to cancel with this log, but we can't cancel all three of them at one shot, right? We can't do that. So we've got to combine the two logs on the left so that we only have one log. Make sense? So now all I have to solve for is 5x squared equals 125. Okay? What first?
Square root, right?
Divide by 5. First, x squared equals
25.
25. Square root, x equals 5. Now, technically, x squared equals plus and minus 5, right? Because we put the square root in there. But look at this guy right here. Log base 2 of x. If I try to plug a negative 5 back in, you cannot take logs of negative numbers, right? We've talked about that before. It ends up with an error in your calculator. So, really, 5 is the only answer, right? Okay, so there's that. All right, so when log equals log, you may have to simplify beforehand, but you cancel the logs out. That's strategy number 1. Okay? What? What? Okay.
Next.
All right, I'm going to say up here at the top in your little thing, I'm going to say or ln equals ln, because ln is the same thing as log, right? So if you have two ln's equal to each other, you can cancel those two off, right?
Yeah.
Okay, moving on. Good?
Yeah, good.
Okay, log equals log or ln equals ln. Okay, now in the second example, we have log equal to a number, or we have ln equal to a number. Okay, so this is what you do when you have log just on one side and not on both sides. You can't just cancel them out. Okay, what?
Hold on.
Okay, I'll come back up and tell you what you do then. Okay, all right. Okay, let's go on down. Let's look at this guy. Before we can even like fix him, we've got to combine the two ln's, right?
So the ln
Plus means multiply, so we have ln of 2x equals 2. And we have to solve this thing. Okay?
Do I invite the 2 over?
No.
Darn.
No.
I tried. Yeah.
No. No. Because you can only if you add it to one side, you got to add it to the other. So now we'll have two ln's on the one side. That one. What is ln equal to? What is ln?
Put e on both sides.
Log base e, right? ln is equivalent to log base e of 2x equals 2, right? Okay? Right? That's what ln is. So I rewrite ln as log base e, right? Okay? Now, you have a log on one side and a number on the other side. Make it an exponential function, right? What's the base of the exponent going to be? E to the second power equals 2x. Okay? What is e to the second power? It's a decimal number. It's really ugly.
I forget which one.
7.389.
7.389. Okay? Equals 2x. And then divide by 2. Divide by 2. X equals 3.695, something like that. Okay? So, if you have a log on one side and not a number on the other side, and not a log on the other side, a number on the other side, we have to change to an exponential function. Okay? That's for both of them, except ln, I'm going to put a little star underneath of ln. Change to log base e first. Okay? Change to log base e first. So if it's a regular log, like log base 2 or something, you don't have to change it. But ln, change it to a log base e so it's easier to change to an exponential function first. Make sense? Good? What? Back to the example?
Yeah, the one with like example 6.
Example 6 right here? There you go. Okay. Here's your paper. We will not turn this in tomorrow, so it's not due tomorrow, but it's a very highly good idea to try to work through 1 through 16 on Fred's side. Yes. Yep.
Can you go back up to the shortcut thing?
Right there. Okay. Oh,
That's
I gotta
the
stop the
front
video.
side.